Okay, so number one, explain the difference between condensation and evaporation.
Evaporation is a liquid to a gas.
So you're going to be the one
And condensation is
what the
a
temperature is in the water. You need to focus on these
is
questions.
a solid to a
Because
liquid.
these are going to help you with
Gas to liquid. They're complete opposites, basically, right?
Yes.
Okay, so our recorder, who's that?
Yeah, so you're going to be the scientist.
Recorders.
The youngest? That's
You're a
you?
scientist.
No, I'm the youngest. Remember, you're older.
Oh, yeah.
Okay, so that person's gonna write that answer down.
So this is
It's
liquid.
going to get...
So you just write evaporation and is liquid to gas, and then condensation is gas to liquid.
I don't
they're
want to
opposite.
get burnt.
No, it shouldn't be on. Did you try to turn? It's not on.
Here is a glass.
It's not on. The thing, it's not on. It's unplugged. It's not on.
But that's after you guys
It's not on.
do this together.
Gas to
Evaporation is when the water gets recycled.
Am I spelling liquid right? I. And then what else? And then condensation, gas to liquid. Gas to a liquid, gas to a liquid? No, liquid to gas, gas to liquid. They're basically, you can put in parentheses, opposites.
There are different.
There we go. Opposite.
What do you need to read it for?
Okay. Oh, gas to liquid. Can you erase that for me? Huh? Erase it for me.
Yeah, you're right. What is condensation? What is evaporation? Huh? Evaporation is when the water
When the water goes up, and then it turns into gas.
And then you can put,
Because
yeah.
why?
Because that's it, so absorbing it.
Yeah, why? Because of the heat.
Okay. Chatty is the Russian. Yeah. Okay. Second question. What is the process of precipitation? Precipitation. What did you name? You were like this.
Are you guys helping her answer all the questions?
I was going. What? I know, but I was. Okay. What is the process of precipitation? I forgot what precipitation. Me too. This one is.
Okay, so let's get our science book out. Look it up. Where's our science book out?
I have one.
You have one? Let's get our science book. I believe it's page 160.
Can we use those on the book?
Yeah, you can use your science book.
I'm fine.
Yep, 160. Okay,
Precipitation.
read it.
Rain, snow, sleet, freezing rain, and hail are types of precipitation that fall from clouds. That the type of precipitation depends on the temperature of clouds and the temperature of the air between the clouds and the ground.
Okay, so basically the process of precipitation is you have to have evaporation, condensation, and then it turns into precipitation. So you have to have condensation. So this would be the process to get precipitation right here.
So you have to evaporation, then condense.
Guys, if you need help with vocabulary words from the worksheet, you can grab your science book. Grab your science book and look it up.
And it's right here in the book. Okay.
It's okay. My phone's good. You're good. I got it. You're okay.
I went to lean in it, my elbow accidentally accidentally. And then it makes
Oh, it's fine.
precipitation.
I really like how this group is using their resources to answer their critical thinking questions. Yeah? What? Excuse me?
And critical thinking?
Yeah, I like how this group is using their resources to answer their critical thinking questions. That's all.
Okay. Why?
That's
I almost
a
done.
hint to use
Girl,
your
you just started.
you have, like a textbook or your notes.
I know. Girl, you gotta like write quicker. Yeah, and hold that. You don't know how to spell condensation. Let's just look here. Has to show both. No, it doesn't. This does. No, it doesn't. It just has to show what Miss Howell is doing. You said precipitation? You said too? It's a whole cycle.
Why do you feel cold?
Alright. Why do you feel cold when you leave a swimming pool? Oh, because the water is warm and then the air is cool, cooling you down. So the water is warm. Water feels warm. Wait. I'm gonna need warm eraser. Thank you.
So there's a lot of air, but the force of
You only need one. You only need one. You don't need two of them. Just one. So you both don't have to write on both papers.
Oh, okay.
So you just need one. Why do you feel cold when you leave a swimming pool?
Like the water feels warm to you after a little while, and then the air's blowing on you.
But in our reading that she just did, when we were talking about the water, what did I say? Evaporation, condensation. Which one did I say? You remember?
So everyone,
No?
okay, so
Believe it was
you need
condensation.
an original temperature before your water starts to get hot. So you're gonna drop it in, watch the red liquid rise or fall, and write down the number that it is at.
So we're starting at 1240, right? 1240.
Almost. We're not there yet.
The condensation mix.
From your skin, the water. Because your body's creating heat, so it's going to create this condensation. Like remember when you're sweating? Your body's hot, but it needs to keep cool, so it's going to create condensation. It's going to create that water, the sweat. So when you get out of the pool, you're warm and you're going to cold air. So you're basically your body's temperature is going to come up, so you get goosebumps, you get chills. But you
David and Ash,
So
are you guys
the water creates condensation on our body.
That's what I believe. Yes. Okay. That's what I think. Let me check.
Creates
Ash, are you the
condensation on our. Can you erase this? Only one of us needs to write it.
Raise your hand.
Okay. So first one was this. You're supposed to be doing this. Can I do this?
Okay, I was wrong. Evaporation.
Or do I evaporation?
Yeah, because you're getting out. You already have the water on you, and the water's going to evaporate. And it's creating that body heat. So it's evaporation.
So
I swear it's cold.
we're supposed to get what's it called?
Wait. Okay. So move your desk. You don't want the hot plate on the purple.
In your groups.
It's over there.
Do you have an outlet over here?
I'm the youngest. I will be the reporter. You will be the equipment manager. Go to the next page.
Don't touch it.
It's right next to me.
Okay.
So I'm the reporter.
I'll be the scientist. I'm gonna get the water.
You're the equipment manager.
Which one's the equipment manager? So I do this, right?
That has nothing to do with us.
Okay, never mind.
And then Miss Howell is our scientist. So circle scientist for Miss Howell.
That one was Howell. Or scientist. I can't read.
Okay. So we got our water. We have who we're gonna be doing. What our parts are, right? Procedures.
You the thermometer. You will read the.
Are you M-I-S-S or M-S? M-I-S-S?
MS.
Okay. To use the thermometer, you will read the numbers on the side under the S in Celsius. The red liquid in the thermometer will rise or fall. You will write the temperature you see in the chart on the next page. You use beakers, hot plates, a thermometer, and water to perform an experiment. Make a hypothesis. What do you think will happen when the cold water is put in the beaker and placed on the hot plate? Make observations and take the temperature of the water before the water starts to heat. After 2 minutes of the water heating, after 5 minutes of the water heating, after 7 minutes of the water heating, after taking the temperature each time, the reporter will write the observation of the group in the spaces provided. To gain all points, you must have 3 observations. What is your conclusion? The hot plates are very hot. Okay. So we first.
Okay, so what's our hypothesis?
We are.
What do you think's gonna happen when we put the beaker on the hot plate?
I think what would happen is it's going to heat up the water.
I didn't plug it in, they did.
I think the beaker is going to rise.
Okay. So the temperature's gonna rise, right? The temperature's gonna rise.
Temperature.
Do we think there's going to be any evaporation? Do we think there's gonna be any condensation? Precipitation?
I think there's gonna be condensation because this is cold. This is a cold liquid, and that is hot. So when that reacts, it'll get water outside of it.
Okay.
The
So
temperature.
do you think there's gonna be evaporation? Because to have condensation, we have to have evaporation, right?
Yes.
So we're gonna have both of those.
Temperature is going. Don't worry, Lily. I'm the only one writing it. I'm the reporter. Temperature is going.
Does she want me to write something too? Does she want me to
No,
write?
you're good. Just turn it in one sheet together. You're gonna have a worksheet afterwards, and you guys
Going
do separate.
to.
Can you erase it?
Fine, just leave it. Just leave it. I think the temperature is. It's fine, Lily. I think the temperature is going to rise, and I think.
I'm trying to smell it.
And I think there will be there will be condensation. Okay. I'm gonna touch it. I'm not gonna touch it. I'm not gonna touch it.
I I didn't write the book. So.
Okay. Now, our observation.
I don't write it.
We're starting at 12:47.
So now? Wait, we gotta wait for Miss Howell. Okay. Dagger over here.
We have to get cold.
Ready, guys?
Yes.
All right, we made our well, leave it in there. Leave it in there. We're gonna leave the thermometer in there the whole time. Okay. So, what is our measurement of the temperature of the water right now at rest?
Right now, it is at. Looks like about 80
or
70.
no, or 70. Looks 70.
Like
72?
70, yeah,
72.
or
Okay, so we're at 72 now.
72.
No, that's not at 1 minute. We haven't put the beaker on. So put it 0 minutes up here. It's 72 up here. Our observation is
0.
what we think right now that nothing's happening. It's just chilling, right? All right. So we're gonna look at the time. So 12:49:20. Put it up here. Let's see the temperature. See what happens.
Oh, it looks like it's starting to rise a little bit. Yeah, it looks like it's starting rising.
Hang on. There's one down there. You're not plugging in. You're not plugging in. You did your hypothesis? Okay.
Yeah, like a 74 or 70.
Okay. I gotta get your water.
Oh, now it's at 80. Looks like 82 or 83.
All right. So right now, this is our minutes up. We're gonna look at it. It is at, I would say, 84.
Yeah.
Okay, 84. Nothing's happened yet. Well, there's some bubbles down here. There's some bubbles creating down there. So maybe there's bubbles are starting to create. So that's evaporation,
Maybe
right?
like a gas
That's
starting to create.
yeah. So evaporation is starting at 1 minute.
Is starting
You can put the number, but you should give
to create. Okay.
Remember, it's
Then with our hypothesis.
We're done?
2 minutes.
Okay.
2 minutes.
Alright, measure it, and right now go. Spend another minute. Go ahead. Measure.
Measure it. Measure it? Oh, shoot. It's 90, it looks like? 90. Still let it rest. Oh, shoot, that's hot. Oh, this is right.
Feels like it.
Set it up.
No, it's cold. It's medium.
It's already almost at 100.
Cool.
So what was our temperature at 2 minutes?
At 9, but it didn't look. We couldn't tell, so we just left it.
It looks
I say
like
100.
100.
100.
Mhm.
perfect.
And now
We're still seeing evaporation.
Did you? Where's your thermometer? Down there. You need a 0 minute temperature. Watch it rise or fall and put it on here.
We didn't connect it. We thought we connected it.
Well, she said she didn't, so it's
I did. I connected it just now. I just connected it just now. They were done.
gotta wait 2 more minutes.
All you have to do is
Alright.
yeah.
So we can't touch it because that's gonna take the temperature of your hand.
And then what is the water doing? The water's doing.
Don't touch it.
Oh
My equipment manager needs to be telling.
I like her cup.
Thank you.
And plus, it'll take the temperature of her hand. Her temperature? I think it's starting to create a gas. No, it has to be 1253.
Oh, you did?
All right. It is currently at 105. No, hold on. 110. 110.
And lower. High five. Thank you for observing. I think it's so nice.
110. We're still seeing evaporation. We're not seeing any condensation yet.
Can I just write an arrow? Like I'm still saying evaporation.
Actually, I'm seeing gases. Hey, y'all get down to eye level. Get down. Look at the water. Y'all see gases rising?
Yeah. Oh, those little the heat waves.
Yeah. I think we should write that down. I'm seeing some heat waves.
And now the desk is getting hot.
Okay, so it launched it, right?
Heat waves. Oh, you know, like whoa. Whoa. So let me put it. It is.
Put it down before it takes your temperature too.
I know that. It is about 100. It's gonna take your temperature, and then I can relate. Like when you're having a grill. I know that, but we have to get the minute. I know. That's why we're waiting. She said to take the temperature.
How many minutes has it been?
Still like 2.
Okay.
Now there were heat waves.
Don't touch it, babe. It's gonna get hot because it's metal.
We saw heat waves in there, and I can relate. Like when you're having a grill, you see all the from the flames and everything and the coal. You can see it.
Yeah.
Just rising.
Oh, it's 12:54.
It's 12:54, Creamy. We have to wait till it's 12:56. Oh yeah. Because we have 2 and 2 and it's 4. And then 5, which we gotta wait 5 minutes. So we gotta. So what should we do when the time passes for 5 minutes? So just watch it like this. Look! More bubbles.
Keep watching. 12:55 minutes.
More bubbles.
We can't observe it. No. It has to be 2 minutes now.
Look at the bottom of the coop. Stop. Just look at the bottom of the coop.
Asher, you watching the timer, buddy? Either one. Wait till you're 2 minutes.
What? 1 minute?
Almost 12:56.
You're doing it like we are.
Yeah.
You're on the
You got it was like
It's not 72, it's 20.
Okay, let's see what it is now. Whoa, it's already, it looks like
Dude, did we write that there's condensation down?
condensation.
What's going on, guys?
It's hot. I can't touch it.
Well, that needs to be down here because that was 110. The temperature now is at 150, and there's condensation now at 150.
Because you only, or your temperatures.
Go ahead, write it down. At 4 minutes.
And the temperatures looks like,
There's still gases, there's still evaporation, then we're starting to see condensation on the side of the glass.
yeah. And it looks like at 152.
Come on, wait a couple more minutes. Oh yeah, that's one. Okay, I write that down. Okay, let's give 1 more minute. Miss T, Miss T.
Miss T.
When it's 9 down. What is that?
Berries.
Blueberries.
Blueberries?
We're only going into 5 minutes this time? Not because there's 7.
There's steam. There's bubbles. You guys should write that down for the observations. I don't see it at all. I see small bubbles.
Steam.
Here. Stand right here. Stand right here. You can see steam.
Oh yeah. You see gas. A lot of gas.
And there's heat waves.
A lot of gas. Heat waves.
Mr. P, is steam precipitation?
I tried to get it. It said, "Are you still there?"
Okay.
I was moving it.
It doesn't have to be. Y'all, are y'all paying attention to the clock in the?
It has to be 1 o'clock.
Now, if you put your thumb down,
All right.
We have to look from it. I'm gonna put theirs in that.
Oh gosh, you can literally like push the marshmallow. Okay.
Yeah, and I can see steam.
Yeah.
So
What's the temperature now?
Oh my gosh. That's where my mom roasts the turkey. 170, 170.
No, it looks like 164.
No, look.
160. Oh yeah, 171. 171. We see
Big bubble, a lot of bubbles, condensation, and a bunch of condensation happening.
condensation.
Liquid to gas happening.
That's condensation.
What's it called? What's that called? What's this called?
Precipitation.
No. What's that
That's
called?
not precipitation.
Not precipitation.
You have condensation, steam. That steam is evaporation, so you're going back down to.
A process. It's going through a process.
Yeah, but I don't think it's getting to precipitation though. If we tracked it like this, and my hand got hot.
walking around back here, and I'm sure another minute and a half has gone by. So almost 2 minutes.
You look at my hand; it's wet, right? That's precipitation.
Okay.
So you see condensation. Right here, it's that
it's
gas
getting
to
wet.
liquid, and that gas to liquid. That liquid turns into precipitation, which is what my hand is.
It's getting wet on the outside.
Nick, I pushed my hand over it. So we're all done, right?
Yep.
Yeah. All right. End video.
103.
End it.